Really lovely with me.
All right. So first things first, do you remember the equation for Hooke's law? What is the equation for Hooke's law? And could you tell me what Hooke's law is?
Oh, the equation is the spring constant by the extension, so F equals kx.
Right. Now, F stands for the force. This is in newtons. K stands for the spring constant, and you could think of spring constant as the what property of the spring. Starts with S.
Um, Stiffness.
Stiffness, yes. So if they ask you what the gradient represents, stiffness, most likely stiffness, right? And X represents the extension. Yeah?
Yes,
And extension will be measured in what? In physics, what do we measure? Length in.
meters.
Great. So we're good. So just keep that in mind. And do you remember what Hooke's law says?
Um, that the extension is directly proportional um to the force acting on it within the elastic limit.
Right, because if it go past the elastic limit, we're gonna empty the spring.
It would not be able to like go back in retract.
Exactly. Right. And I mean it's only have like it's only so far it could stretch a piece of wire, right?
Yes.
Yeah. The extension is directly proportional to the force applied within the elastic limits. Don't worry, I'll write neater. We're just talking stuff. We're just running through stuff. So
Yes.
you know what Hooke's law is? You know what's the formula? Great. If I wanted to find for key, how would I find the key? Or what I have to do on both sides if I wanted to make key a subject?
You have to make it subject.
Hmm.
Um, divide by x.
Divide by x. When you do that, the x and the x gonna cancel off, so that leaves you with k. So k is equal to f over x. Now, if you plotted a graph and the graph was force against extension, what do you think the gradient would give you?
The spring constant.
Correct. Because when you find an gradient, and gradient is the change in y over the change in x,
Yes.
right? So on the y-axis, so remember gradient is y2 minus y1 over x2 minus x1. So if it's y2 minus y1, the values for the y-axis would be force. So it really would be force over the extension. And hence we see now that it's the spring constant.
Yes.
Cool. If you had a graph, just make sure, right? And if you had a graph, but this time it was the other way around. It was extension versus force, then the graph would have looked like wait, just make sure. Yeah, it'll just be like, right. Now, if you find ingredient for this, remember gradient is y over x. What's on the y-axis in this case?
X.
And on x is on the y-axis. No kind of confusing, right? X is on the y-axis, and f is on
Mhm.
the x-axis. So,
Yes, sir.
would I call this the spring constant?
No, sir.
No, that's actually the inverse of the spring constant. So, if we found this gradient to be 5, then to find for k, I would have to raise that to the power minus 1 to invert it. Right? And if you do that, k will be equal to 1 over 5 or 0.2. Understand?
Yes, sir.
Great. Just keep that in mind. Don't ever forget that. Though they like to tire people with the graphs. Don't get confused. So I'm going to run through that one more time for anybody that might be looking back at this recording. If you have a graph of force versus extension, what does the gradient give you?
Um, spring constant.
Right. It gives you spring constant immediately. Why is that? That's because on the y-axis you'd have force, and on the x-axis you'd have extension. So the gradient is y over x. So on the y-axis is force, on the x-axis is extension, and hence we know by the definition, k is equal to f over x. If you make
Yes, sir.
the subject, yeah, that will work out. So if you have a force versus extension graph, we're happy. Great. That's great news. Gradient one time, right? If you have an extension versus force graph this time, then to find the gradient is the same procedure, but if they asked you for k, you'd have to raise the gradient to the power minus 1 or flip it to get your answer. So do you fully understand that?
Yes, sir.
You sure?
Yes, sir.
Good. One thing I need to run through before I move on. So Sheena, if you have a
Yes, sir.
spring just sitting on a table, wouldn't the spring still have a length?
Yes, sir.
Mm-hmm. So would the extension will be 0, right? But would the length of the spring be 0?
No, sir.
Uh-huh. So do you understand why if I have a graph of length versus force, it doesn't start at 0, 0?
Yes, sir.
So try to understand that. So if we read off this coordinate, let me just say this was 8 over here. I want you to read off that coordinate for me. Try to read off that
0.08.
0, comma 8. Now that would mean at this point, that's the length you're going to have when you apply a force of what? Tell me, Sheena.
Oh, 0.
Right. So that's just simply when the spring is there and it's doing nothing. Understand?
Yes, sir.
Oh wait, just correct me if I'm wrong. Enters physics this evening and add maths in the morning, or is vice versa?
I thought about advanced and physics, but I thought I just crazy and yeah.
I don't know why I thought physics was today.
I was just going with it like
I mean, it's only you in class, right? Wait, it's only
I
you in class, so it's not really like a big deal
I don't
because
mind that such party.
I mean it's just you.
Yes, sir.
But should I just should I just stop this one and start add maths?
Oh, I
Wait,
wanted to continue.
say that again?
I said I wanted to continue. What switch party?
Okay, let me just pop a message on your chat, right?
Okay.
Right, right. I don't know why I make that I mix up. That's crazy.
So I just thought I just went with it. I thought that I was going crazy and yeah.
Oh gosh, that's embarrassing. It's not his name. Wait, No, like just imagine, what am I gonna tell a parent? Am I gonna tell them I mix up the dates? That's so bro,
Oh,
that's crazy. Oh, and I mean it's the same link, right? So if somebody join advanced class, they would be here. And I mean it's
yes.
just you. How much?
Don't we have more or less the same people in physics and math?
Yeah. Wait, give me a second. So it's
Yes, no problem.
Yvonne, Vani, and Jilan. Let me just put a message on the chat. All right, let me continue, right? Let me just let me keep on going.
Yes, sir.
I mean, you already love the physics momentum, right? You know,
Yes.
momentum physics. All right. All right. Okay, I continue. So you understand that if you have a spring at rest, you're not applying any force, but it will still have an initial length.
Yes, sir.
And if you wanted to find the if you wanted to find the extension, wouldn't you have to take the initial length and take it away from the new length?
Yes, sir.
Just keep those things in the back of your head. So let's actually do our question now, right? So Hooke's law. What is Hooke's law?
Um, is the ex it's the that the direction of the spring is directly proportional to the force acting on it within the elastic limit.
Right? So the extension of a spring is directly proportional, right? Directly proportional. Oh, by the way, you could just palm message on the AdMax group chat saying class will be tomorrow, 9 to 11. Just for tomorrow.
Yes, sir.
All right, well, I'll put this on the screen, right? So the extension of a spring is directly proportional to the applied force within the elastic limit. And if you want to be extra fancy, you could put in the formula as well. So F would be equal to Kx, and you could say F is force, right? And force is measured in newtons. K is stiffness, and the units for stiffness would be Newton per meter, and X would be extension, and you'd measure extension in meters. Yeah. So that this part over here is optional. But if you want to show them that you're real bad, that's what to do.
All right, sir.
All right. All right. Okay, let's continue. So part B. To determine the spring constant or stiffness of a spring, a student placed different masses M on a hanger that was attached to a spring and recorded the length L of the spring. Table 1 shows the mass and corresponding values of length. Right. So, oh, by the way, Shane, I realized something.
Um, yes.
I mean, odd maths is 4 to 6, right? Now, even if I didn't say that, even if I didn't say that, you still would have been the only one that joined. So, I mean, you know, you know,
Yes.
yeah. All right. So let me continue. So they're giving us a table with different masses. They're giving us force, length, and extension. Now we need to figure out what the initial length is first. So what do you think the initial length would be? Looking at the table, what's the initial length? Tell me, Shana. Look at the table. We know that the initial length would be when no force is applied to the spring.
Also is 70.2.
Right. Let's spell reason for that on the side. 70.2 centimeters is the initial length because it is the length of the spring without a force being applied. So let me know if you understand that.
Yes, sir.
Great. All right. Okay. So let's continue, right? So we need to fill out the table. So using the grid provided in figure 1, plot a graph of extension versus force. Extension versus force. So before we can do that, we need to fill out all of the forces, right? So, Shayna, how would I find force given mass?
I definitely remember this. Um,
Yeah, how do I remember this? F is equal to what?
oh, I remember this. Just now, last time. Just now, I remember this.
Hmm. Yeah, you could do it.
I'm speaking it into being. Um, um, is it? I
Mass
forgot.
time is mass times what? You've got this. Mass times what?
I'm gonna say something about.
You could do this. Okay. Um, Let me give you another hint, right? Okay. Is weight an example of a force?
Yes,
What is formula for weight?
mass times gravity. So
Right.
I think is is it okay? Let me shut up before.
Mass times acceleration.
Yes, so that I want to say that, but I'm afraid I said stupidness.
No,
And
mass times acceleration is fine, right? Is fine. Yeah. So you're good. Don't worry. Don't worry. Right? You need to remember that gravity is acceleration, right? When you drop something, doesn't gravity cause it to accelerate? Tell me that.
yes,
Yeah, it does, right? So either one of these formulas is fine. Now I have a question for you. If you know that force is equal to mass times acceleration, right? Well, weight is equal to mass times gravity. What did they tell us the value for G to use? If not, that's fine. We could always figure that out, right? Um, Gravity is usually 9.8 or what? 9.8 or what?
10,
10. What would I have to multiply 0.10 by to get one?
10,
Yeah, exactly. So we think the gravity constant is for this question.
10.
Correct. So check how we would do this, right? So F is equal to mass times acceleration. You could use W is equal to mg as well, right? The force is 1. The mass is 0.10. Do we have to do any conversions there, or is it already in kilograms?
It's already in kilograms.
Cool. Times the acceleration. Do we know what the acceleration is? Nah, we don't. So we have to find for that. To find for A, I would have to divide both sides by,
Um, 0.1.
right, 0.10. And 1 over 0.10 should give you 10. Right? And the acceleration, the units for acceleration will be ms minus 2 or m slash s squared. Yeah,
Yes, sir.
right? I didn't want you to assume that gravity was 10. I would prefer if you find it. So if that's the case, could you fill out the rest of the table? Tell me, Sheena,
Yes.
if I have a mass of 0.20, how would I figure out the force? I mean, the force.
Yeah, plug back into formula. So 2 equals 0.20. Um,
Wait,
i.e.,
wait, I think you mean to say F is equal to the mass, which would be 0.20 times the acceleration, which we found to be 10.
yes.
That would be 2.0,
10.
right? Jira, you there? Jira,
Yes, I am.
Jira, if I tell you what happened, I come to class teaching physics, right? Normally this session is for hard maths, but I was thinking about physics, so I start physics, right? And we already built up a momentum, Shane and I, so we say let we just continue with physics. I mean, there's not much people. So yeah, that's why physics classes today. I don't know what I was thinking.
Okay, so we're not having physics class tomorrow.
No, we're not.
Wonderful, I could sleep.
Yeah, you could sleep. If this works out better, we could always have physics on a Friday and add maths on a Saturday. We go see though, right? So I hope everybody go with this, right? So Jada, tell me if you're confused. Be honest with me, tell me if you're real confused.
I don't think I'm real confused, but I kind of don't know what you're doing because I'm not come here.
Okay, so last class we looked at Hooke's law. I'm not sure if you watched the recording. Did you or did you not?
I watched piece it.
Okay, that is
Like
that
the
that is
first time.
that is not enough. I don't watch the full thing.
It's not my fault, I don't have plenty time.
Okay, I understand that as well. I understand that as well. Time is very something that's very limited. So look at this, right, Jada? Do you understand that if you apply a force to a spring, the spring would extend? Yeah?
Yes.
If you wanted to find the extension of the spring, wouldn't you just take the new length and the original length and subtract them from each other? Let
To
me run that
find the
the,
length
the extension.
extension.
Yeah.
Yes.
Right? So to find extension, you would say the new length minus the original length. And won't you agree that the original length of the spring is when you apply no force to it?
Yes.
So when the spring just lying down, no force is being applied to it. So that would be the initial length. So tell me if you understand that. So if
Yes, I
you
do.
so if you have a spring and you're not applying a force to it, well, it's just lying down there. That's its original length. Cool. It's only when you apply a force, it is extend. All right, nice. Glad that you got that. Do you remember how to find force given mass?
I think so.
All right. Basically, force is equal to mass times acceleration. That's the main formula for force. Additionally, you could have also used the formula weight is equal to mass times gravity. Because remember, weight is a force.
Right.
So let me explain this experiment here. Imagine you have a retort stand and you hook up the spring to the retort stand and you are applying masses to the spring. Anything more mass you apply to the spring will start to extend.
Yes.
Yeah. Right. So I hope you understand that. So this is essentially what's going on. Now, depending on the mass we attach to the spring, it would exert a different amount of force. So we need to figure out the force that would be exerted on the spring, given the mass, right?
Yes.
So the first thing we need to do is figure out what the acceleration is. Now we're on Earth, and gravity is what is causing things to accelerate downwards,
Yes.
right? So for me to figure out the acceleration, I used this scenario. So I knew the force here was 1 and the mass was 0.10. So if I plug it into this formula, so F is 1, right? So F is 1 and the mass is 0.10 by acceleration, and I divide both sides by 0.10, my acceleration is 10. Am I that confusing you?
No.
Okay, nice. So you understand acceleration here is 10 due to gravity. So
Yes.
how would I find the force as a result of the 0.30 kg mass here. I would multiply the mass times the acceleration. So what's the mass here?
Zero 0.30.
Right? And what did we find the acceleration due to gravity to be?
10.
Right? What is 0.30 by 10?
3.
Right? 3.0. Now in physics, you want to follow the standard of the table. So Jada, notice everything here is to one decimal place, right? So follow that standard. All right. What do you think 0.42 would be in terms of force? Make a wild guess. What do you think?
Like the answer?
Yeah, the final answer.
4.2.
Right. We have the next Einstein here, guys. I joke. Yeah. But big up yourself. Yeah, I think you see the pattern by now. You just shift in the decimal place. One space to the left. I mean saying, what I'm saying. I mean one like two spaces to the right, right? Like that. No, what I'm saying, no, the first thing I say I was correct. Anyways, the last one, Jada, 0.50. What would that be?
5.0.
Cool. Now we need to figure out the extension. Remember, I told you that if you want to find extension E, that would be the original length, LO, minus the new length, which is just L. Tell me if you understand that.
Yes.
Wait, what's it? It should be the other way around. L minus LO, right? So if you stretch the spring and the length of it is now 74.4 and the original length was 70.2, how would you find the extension? So let's make sure we get in 4.2 here. So the original length was 70.2, and that's when you apply a force of 0 to it, right? Like you're not applying any force. And if you apply a mass of, if you hook up a mass of 0.10 kg to it, then it's going to stretch. And it's now going to be 74.4. So how would I find the new length? So this is the original length, and this is the stretched length. How would I find the extension? Tell me, Gino, how would I find the extension? So
Minus the
so first of
the
all,
new length to the minus the original length.
right. So what's the new length?
74.4.
Right? And the original length was 70.2. What is 74.4 minus 70.2?
4.2.
Right? Just to confirm, did we get that in the table?
Yes.
Yes, sir.
Right? So we're going good, right? We're going good. Now, could somebody tell me how I would find the extension for a length of 79.2? How would I find the extension for that?
79.2 subtract 70.2.
All right. Jida, were you tempted to say 79.2 minus 74.4? Be honest with me. A lot of students usually tempted to do that.
No, because 70.2 is the original
Good.
length.
Good. Right? And 79.2 minus 70.2 is just 9. So that's going to be 9.0. Right? For the 83.9, we're going to say 83.9 minus 70.2. What would you get? What is,
13.7.
right? 13.7. Okay, last one. That's going to be 92.7 minus 70.2. What would you get?
22.5.
Right? 22.5. Was it hard to fill out the table?
No, sir.
Nah. So, Jira, let me just run through a couple of things, right? To fill out this table, you had to know the formula for force. Now, force is equal to mass times acceleration. Now, Jada, any table, weren't we given, like, at least for this one, weren't we given the mass and we were given the force?
Yes.
What was the only thing we didn't have in this formula?
Acceleration.
So we found for acceleration first, so we could have applied it to the other masses to get the other forces. So I hope you understand that. Let me know if you're okay with how I got the forces and how I got the extension.
Yes, I understand.
Nice. Now we want to plot a graph of extension versus force. So Jada, whichever one comes first is going to be on the y-axis, and whichever one comes second is going to be on the x-axis. So which one did they mention first? They said plot a graph of what first,
Extension.
right? Right? Extension E. And what do they want us to plot on the x-axis?
Force.
Now, could you tell me what the gradient for this graph would be? Would it be k or would it be k inverse or 1 over k? So Jira, you wasn't there in the last class, right? So did you watch the part where I mentioned the equation for Hooke's law? Did you see that part? Where I talked about the equation for Hooke's law?
I don't think so, because I would have remembered.
All right. So the equation for Hooke's law is F is equal to KE or F is equal to KX. E or X mean the same thing. F is equal to KE. So if I wanted to find for K, I would have to divide both sides by what? If I wanted to find for K, what would I divide both sides by to find for K? I just want K on one side. Tell me, Jira. If I want to find for K. So K is the spring constant, by the way, I should mention that. K is the spring constant. So I'll help you out. If I wanted to make K the subject, I would divide both sides by E. Why am I doing that? I'm doing that so I only remain with K on that side. So in other words, K would be equal to force over extension. Tell me if you understand that.
Yes, I do.
Okay. And remember in yesterday's maths class, I showed you how to find gradients.
Yes.
Right, how to use that in physics. So if you recall, the formula for gradient is y2 minus y1 all over x2 minus x1. Does that ring a bell?
Yes, it does.
Nice. So let me ask you a question. Check this. In this graph, what is on the y-axis?
Extension.
So when you find the gradient for this graph, you're really finding extension over what? What's on the x-axis?
Force.
So you're really finding for E over F. Is that K? Is that K?
No.
What is K?
F over E.
All right. What's the relationship between F over E and E over F?
They just switch places.
Yeah, they are the reciprocals of each other. Just flip them, and yeah.
Yes.
So if I wanted to find a gradient for this graph, all I would do is I would say K would be equal to the gradient to the power minus 1, or you could just simply flip it. Like if you got the gradient to be 7 over 9 here, then the spring constant would be 9 over 7. Tell me if you understand that.
Yes.
Okay, great. Don't forget that. Keep that in mind. Keep that in mind. So the spring constant K would be M inverse, or you could just say 1 over M. That's fine. So another thing students have a problem with is plotting the graph. So Shayna, remember I said extension is on the y-axis and force is on the x-axis. Remember I said that?
Yes, sir.
I think we should try to come up with the coordinates. So we're gonna put x by force, so you can know that's the x-axis. Okay, and I'm going to put y by extension, so you know that's going on the y-axis. So if you want a set of coordinates, remember a coordinate is given by x, then y. So this first point would be 0, 0.0 and then followed by 0, 0.0. Right? Could you give me the next point, Shina? What would the next point be?
1.0, 4.2.
Right? Jada, could you give me the next point?
2.0 and 9.0.
Continue.
3.0 and 13.7.
Right?
4.2 and 18.0.
And the last one is
And 5.0 and 22.5.
So I
great.
have a question. Should I be getting graph page right now?
If you need a graph paper,
Yes, right now. Should I go for one?
yeah, you should go for one.
Okay. Very unfortunate. Okay.
Yeah. Right? So, Jada, do you have graph paper? That's the question.
I don't, but let me go bully my sister for some. I'll be back.
Nice. I like to hear that. Cool.
I'm gonna say I'm back.
Okay, you have the graph paper?
Yes.
Okay, cool. Right. I really feel like today, my brain just, oh,
Should I me too? So my Wi-Fi. We should take a moment to appreciate
oh,
this.
you didn't drop once.
And only at the start.
Let me not
One
jinx.
time.
Let me not jinx it. Don't let me. Right,
Yes.
so while we wait on Jada to get her graph paper, I would like you to put down your y-axis and your x-axis. Put the axis titles, put the title for your graph, figure out what scale you're going to use, and put it to the right and start plotting.
Oh, okay, okay.
Mhm. All right, Jida, did you find any graph paper?
Unfortunately, not.
Oh, shucks. Well, you know how to get then.
Definitely.
Now, I know use a big driver and things, so
Hey, hey, hey.
yes, you don't have no excuses. If you and I know, hey, Jida, I don't know how you gonna feel about this, but I always thought you was from Barapur. I don't know why.
What?
I don't know why. I don't know why.
Hey, at least it's better than somebody think I was from Penal, right?
Wow. You know who's from Pinal?
You.
Yes.
Nah, don't mean it in that way.
That's crazy. Hmm. Well, technically DB, if we're being specific. But DB, Pinal, same difference. But I feel like Pinal have a more like have a greater stigma attached to it.
Yes. You know where I'm from, right?
Yeah, Maraca. I'm no my arrow. I say
Yes,
Maraca.
Caracas.
My
I
arrow.
wish.
My arrow. Beach every day if you live in there. Beach every day.
That is so
You go live on
untrue.
that beach. All right, so let me do the question, right? So here what since you don't have graph paper, you will do it with me on the board. Yeah. So they said to plot a graph of extension E versus force. Now in physics, you have to be very particular with your axes. So let me show you what I mean by that. So if you want to get the full 8 marks, you need to label your axes. So this axis here, it was extension, yeah? This was extension,
Yes.
right? Because it said extension E versus force. So you're gonna put extension E, and in brackets, you should put the units. So the units for this would be centimeters, right? Tell me if you go with that.
Yes.
Right? You could write it like that, or you could choose to write it like this. So E/cm. All right?
Yes.
Over here,
Also, if you're hearing my dogs, please tell me.
I hear them.
Oh my god.
But that's okay. That's okay. Right? And this would be force. Now, force F is measured in newtons. So let me know if you're okay with how I label the axes.
Yes.
Right? So now we need to come up with an appropriate scale. So from the coordinates, I want you to tell me the smallest value for force and the biggest value for force.
The smallest value would be 1, unless it's 0, point
As
0,
0. Right?
right? Okay.
Right?
And the
Biggest value.
largest value is 5.
Correct. So we in physics, your graph, whatever scale you choose, it must take up more than half of the page. So you can't come and say 1, 2, 3, 4, 5. You can't do that. Do you understand? You can't do that. Because that not taking up half the page, right? It has to be, it had to be like over here. You understand what I'm saying? You can't just trick up the graph to the corner. I mean, if you understand what I'm saying. Jada?
Yes, I do.
So this is what we're going to do instead. We're going to say every 2 blocks is 1. Now, if I do this, it's going to space out the x-axis big enough. So that's going to be 1. It's going to be 2.0. It's going to be 3.0. It's going to be 4.0. And it's going to be 5.0. How you feel about that? And this could be 6.0. Does that look like it takes up about half the page, if not more?
Somewhat, yes.
Okay, cool, cool. So we good, right? Now,
Yes.
here's the harder part. We need to figure out the scaling for the y-axis. So what is the smallest value on the y-axis and the biggest value on the y-axis?
The smallest is 0,
And the biggest value is?
22.5.
Right, you can understand how this might be a little hard. So let's come up with some ideas, right? Do you have any suggestions as to what scale I should use to occupy most of the space on the y-axis? Tell me, have any ideas? Or this one a little tricky?
Not anymore. I was counting like if you were to put 1 block as 1,
But I think it went up to what, 16 or 20?
20.
So you can't do that, right?
Yes.
And if you go to say that every one is two, let me still go up on 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. No, I feel like we could figure out something that would take up more space still. All right. Still think we could come up with something better. What about if we say every two big blocks is five? Let's see what would happen over here. So 5, 10. Wait, I wonder if that will work. What if our first plan was better?
I don't think it would be big enough.
Hmm. Yeah, I don't think so. Watch, because we're gonna push 20 right here. So the first scale was better, right?
Yes.
Yeah, the first one was better. So let's just use that instead. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Did I make any mistakes? Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, right? 26, right? 28. Cool. Now in the exam, we should most likely fill out the axes, right? You should do that. Should like go up all the way up to the head of the arrow. Right? But we're fine where we are right now. So Jada, the first point is what? What's the first point?
0.0 and 0.0.
So that would be right here, right?
Yes.
Cool. Next point is 1 comma 4.2. Now this is what I'm going to advise you to do. We should figure out what one of these small blocks is. So Jada, how much small blocks we have inside this big block?
5.
So hence we can write that 5 blocks is equal to 2.
Yes.
So what would one block be?
2.5.
2 over 5.
Oh, okay. Right. Okay.
Let me show you how that working out. You can think about it in two ways. You're going to move across the 5. If it was 5 multiplied by b, then it's going to turn to 2 divided by 5. Another way to think about it is you want to find for one small block. So you would divide both sides by 5. Yeah.
Yes.
So what is 2 over 5 as a decimal?
0.4.
0.4. Cool. 0.4. So if that's the case, then this would be 0.4. This would be what?
0.8.
1.2, right? So on and so forth, 1.6 and then 2. So that begs the question. If this is 0.4, what do you think this would be?
0.2.
Great. Great. So we could answer the second point. The second point is 4.2. Wouldn't 4.2 be right here?
Yes.
Because this is 4, this would be 4.4. So 4.2 would have to be in the middle. And we run that back one more time.
I understand it.
You see
But
enough?
you could if you want.
Jedi is no shame thing here, no.
No, I understand it.
Okay.
But you could if you feel comfortable.
It's not about I feel comfortable. It's about the smaller feeling comfortable. So okay, you understand that 5 small blocks is equal to 2.
Yes.
So we divide both sides by 5 to find for what one small block is. And we get 0.4. So if that is the
Yes.
case, every small block that count is 0.4. Right? So we starting at 4 over here. And so if you add 0.4 to 4, wouldn't this be 4.4?
Yes.
Right? It's gonna be 4.8, 5.2, 5.6, and then 6. Cool. All right, the next point, 2 comma 9. All right. Now let me show you a hack for this. Wouldn't 9 just be in the middle of 8 and 10?
Yes.
So we could just say 2 and kind of guesstimate that it would be over here. Yeah. All right. Cool. The other one is 3, comma 13.7. This one might be a little hard, but here what? It wouldn't penalize you much. Once it's looking like 13.7, you're getting marked. So 3, 13.7. All right. First things first. Let me try to figure out how we're gonna do this. So we know that one small block is what? What is one small block?
0.4.
Right? So this would be 12 point.
4.
This would be 12 point.
8.
This would be
13.2.
right. This would be 13 point.
4.
Yeah, sure.
No, 0.6.
All right. And so 13.7 would be like somewhere over here and
In the middle, kinda.
not exactly in the middle.
Because then it would not give you up to 14. But yes, I understand where you're
So it
going
go
with it.
somewhere over there. Now they're not gonna be too hard on you, but it have to be in the general vicinity. So like it's gonna be a little below the half mark because any half mark that would be 13.8. Understand? Because actually this would be we know that this would be 13.6 and this would be 14. So what is in the middle of that? Do you know? An easy way to figure out that is
13.7.
just is add up 14, right? We take the mouse and yeah, it would well, it wouldn't be. Wait, did I say 13.8 initially?
I think so.
Yeah, 13.8 is correct. Yeah. So if the middle is 13.8, you'd have to go one block, like very like not one block. You just have to nudge a little below to show 13.7. So let me know if you understand that.
Yes, I
Right.
do.
Nice. And then we have 4.2, 18. Now we need to figure out what one of the small blocks is equal to on the x-axis. So how much small blocks we have all together on the x-axis? Like check it out. From 0 to 1, how much small blocks do we have?
10.
We have 10. So in other words, 10 small blocks is equal to 1. So how would I find for one block?
You divide
I would divide both sides by,
10.
right? Because I want to find for one block. So 10 into 10 is one block. Right? One block is equal to 1 over 10, which is 0.10. Yeah?
Yes.
Nice. So 4.2 would be where? So if we count in, this would be 4.1 and this would be 4.2. Yeah, or no?
Yes.
Right, so 4.2, 18. It's an easy one. 4.2, 18 will be right here. Okay, yeah. So you're okay with everything I've done so far? Let me know.
Yes.
All right. Then we have 5, 22.5. So we don't have to do no fancy work. We know what 5 is. 22.5. All right. So this would be 22 point what?
4.
The 22.5 would just be like right here, right?
Yes.
Cool. Shayna, we talk too soon. I see you just on drop off.
Yes,
Right.
we jinx it.
You jinx it. Hey, any of you ever grow up watching Winx? Or you know what Winx is?
Yes,
Jada, you know about Winx?
Yes.
Okay, cool. My sister used to really watch that and well, I used to watch it too. I mean, I find it was a good show, to be honest. Right? So here what? Jada, do all the points line up perfectly?
No.
But if you were to line up your ruler, would most of the points line up?
Yes.
So let me tell you about something, right? So in physics,
We have
So
something called our best fit line.
a best fit line, that's one thing.
Mhm.
And you would also need to look out for like bad points, right? Points that far from the line. So you see how that 1 point just like it's like a sawtooth. It just it's not supposed to be
A
there.
place.
Yeah, think about it like this. Imagine you're doing a lab and you make an error and you take a wrong reading. That's what that point would be. All right.
Right.
Under normal circumstances, normally the points wouldn't be so far apart, and if they were, then you would take a ruler and you would try to align it in the middle and you would draw the line, sort of to be an average of the points you have. And that's what best fit is. But since we have I cannot see what I'm looking for, erroneous reading. Since we have 1 point that's so far off, we're just gonna ignore it. And I'm just gonna draw the line. So let me know if you're okay with what I did here.
Yes.
Right. Cool. Right. Calculate the gradient S of the graph. Now we just oh wait, I'm not finished, right? So there's two more things you need to do. If you want to get 8 marks in physics, you need to put the title for your graph and you need to put the scale that you used, right? So Jada, before we move on, let's just put the scale. All of this is marks. So on the x-axis, right? So on the x-axis, what did we say? We said that we said that 2 blocks is equal to, what did we say? What did we say?
Every 2 blocks is equal to 1.
Right. Now, you ever measured the distance for one big block on graph paper?
2 centimeters.
Right. So is really centimeters. So you're going to say that on the x-axis, 2 centimeters is equal to, and you have to be careful here, right? Physics is like the units are very important. So on the x-axis, we are measuring newtons. So you would say every 2 centimeters is one what?
Newton.
Right, 1 Newton. And you would say on the y-axis, we said every 2 centimeters is equal to what? No, we didn't say that. We said every 1 centimeter would be equal to what?
2 centimeters.
Mm-hmm. Right? Cool. Now we need to put a title for your graph. So the title is really simple. You would just say graph of extension, right? Graph of extension E, comma, centimeters versus what? What do you think? Versus what?
Force
Right? Force,
slash newtons.
right? Proper data. Greater. Yeah. Right. I'm gonna feel okay with that.
Yes.
Great.
I
Sheena.
have a question.
Yeah.
For the scale, we teachers told us to always I know I think it's preference, but to always use 1 cm, like 1 cm equals 0.5 newtons. Like, does it really matter? Because I don't think it does, but I think it's just a preference thing for her. Oh crap. I think it's just a preference thing for her. So yeah.
Yeah, that's our preference. Like in when you do any exam, and if you look at all the solution videos online, nobody just follow that standard. The first time I hear that standard, when I was in
Okay.
secondary school, I would have do it like this. The
Okay.
the the rule is you can't use a scale that is a multiple of 3. That's something you should know. Right? So Jada, you can't say 3 blocks is equal to something. You can't say 3 centimeters is equal to 1 or 6 centimeters is equal to 1. You can't do that. And if you're wondering why, that's because if you divide something by 3, most of the times it's a bad idea. Think about it like this, Jada. If you have 1 over 3, wouldn't that be a recurrent decimal? That'd be 0.333 going on. And you don't want that. You want when you decide on a scale, it should be like each small block should be a nice rational answer, right? Just to reiterate, right, Jada? If I said that, every three blocks is one, let me show you why that would be trouble. So altogether, you would have 15. So 15 blocks would be equal to one. And you're gonna end up with 1 over 15. Where's 1 over 15? Plug that into the calculator and let me know what you get.
0.06.
Recurrent, right?
Yes.
You understand why we shouldn't use that? We rather use 0.10, which is like a nice decimal, or would you prefer to use 0.6666666? Which one you would have? You would have to round it off. What
Yes.
do you prefer to use? The 0.10 ends.
Yes.
So let's just go over the rules for a graph. You need to label your axes. You need to put a title for the graph. The graph must take up more than half of the page, and you can't use a scale that's a multiple of 3, right? So we want to calculate the gradient of the graph. So to find gradient, how much points you need, Jada? How much points do you need? From yesterday's session, do you remember how much points do you need to find gradient?
2.
You need 2 points. So the easiest point, so here what? I would advise you to use points that were not given to you. And the reason for that, Jada, is because remember, in physics, you would do an experiment, you would take down information, and then you would plot a graph. So these points are experimental values. You don't know if they're correct. Or when you do the best fit, it's kind of average of all of the points you get. Understand?
Yes.
So it's only when you draw the graph and you do the best fit, then it would actually read points off from the graph. So you're not going to use any points that were given to you. That's another thing you should note in physics. So are you seeing any nice points we could read off? Let me start you off. Let me see if I can see any nice points. Mm, am I seeing any nice points? We could potentially use this one. All right. So Jira, if you want to read off a point, put our X by it to show that you're using that point and put the coordinate for it on the graph. So tell me, Jira, if I wanted to read off that point, what would be the X value for that point?
1.8.
Yeah, 1.8. And what would the Y value be?
9.2.
Are you sure about that?
I think no, 8.
8.0, correct?
I was looking at the other one. Sorry.
I feel so. Right. And let's read off another point. If you look closely, um, let me see how good he is, right? Do you think you'd be able to read off this point, this awkward point over here? Let me see how good he is. See, if you want to read off that point, you would have to read off the X value first. And what's the X value?
You could scroll down a little bit, please.
The X value, I don't think you need to see any more information to figure it out. Check it out.
3.4.
Yeah, it'll be 3.4. Okay, 3.4. And now we need to figure out what's the Y value. So that's looking like what?
15.2.
15.2, that's correct. So do we have the information that's required to actually find the gradient? Tell me, yes or no?
Yes.
Right. Sheena, you okay? Sheena, let me know if you're okay.
Yes, sir, I'm okay.
Yeah, sure. All right.
Oh my God, yes, sir, I'm following.
All right. So Jada, which point do you want to call the first point, and which point do you want to call the second point?
1.8 and 8.0 could be the first.
So you want to let this be the first, so x1, y1? Yeah.
Yeah.
Okay, and it doesn't matter by the way, right? And so if we wanted to find a gradient, it would be now typically we use common M to represent the gradient, but in this question they said calculate the gradient, capital S. So we're going to use that notation here. So you're going to write the formula for gradient first. It's y2 minus y1 all over x2 minus x1. Right? What is y2? Tell me, Jada, what's y2?
15.2.
What is y1?
8.0.
Right? And we're going to say x2 minus x1. Now, what is x2?
3.4.
What is x1?
8.0.
1.8.
1.8, sorry.
I'll get you there. Right? So if you have a Casio, you can plug this straight in. I mean, if you have a Sharp, you could do that as well. But Jada, would you prefer to work it in parts or work it separate, like work it one time? Parts or one time?
It doesn't matter, but
Okay, do you
parts, I guess.
parts? All right. Do you have a Sharp or a Casio?
Sharp.
Should get a Casio. But I'll show you how to do it one time with the Sharp, right? With the Sharp, you would have to say open bracket. Why is I now going to say that a virtual calculator is dead? That would not make any sense, right? So 15.2, you'd have to say 15.2 minus 8.0 divided, open bracket, 3.4 minus 1.8, close bracket, equal. When you plug that into your calculator, you should get 9R2 or 4.5.
4.5.
Okay, great. Now, Shayla, did you get that as well?
Yes, sir, 4.5.
Like the exact same thing? Or it's something slightly off? Shayla?
So I use your points, so yeah.
Yeah, but did you get 4.5 or something slightly different from 4.5?
No, I guess exactly 4.5.
Exactly 4.5?
Yes, sir.
Wow, that's crazy. You see, the reason why I'm surprised is, and you could understand, everybody would do their best, but it's slightly different. You understand what I'm saying? Everybody would
Yes, sir.
that's what's slightly different. So sometimes the gradients is different. So Jada, when you do gradients, there's a margin of error, right? So once your graph looking good, you do your best fit properly. Your graph, I mean your gradient could be slightly different from somebody's one, but it'll still be correct. Now, this is a 4 mark question. There's more you need to do. So Jada, just remind me, what was on the y-axis? If you look at the graph, what did we plot on the y-axis?
Extension.
What was the unit for extension? Extension is our length. But
Centimeters.
in this case, we use centimeters, right? Centimeters. Okay. So when I put centimeters on top, all over what's on the x-axis. What is on the x-axis over here,
Force, which is newtons.
right? So you need to put your units in physics. So you could write centimeter per Newton as one way you could write it. Or you could write, does anybody know? Jada, do you know? 4.5.
Centimeters, newtons, -1.
Correct. Big up you. Right? So that's it for S. Now, guys, is that the spring constant? Yeah or no?
No, sir.
Shayna says no. You okay, Shayna?
Yes, so my life is just fun.
Shayna, I feel like use my like spiritual animal. Yeah.
I don't know if to be honored.
You feel honored?
I don't know if to be honored. That seems very unfortunate.
Because I just make real mistakes like you too. I don't know why. So
Oh
I
my.
can relate to you. You know, like in all my exams, I get like 90 something. I just never fully get 100. Or like I get something. I always make some mistake.
Yes, sir.
All right. So Jira, do you understand what it takes to get full marks on a gradient question?
Yes.
So you need to get the correct gradient. I mean, what I say, you need to get the correct answer and you need to put the units associated with it. Now, do you understand why this answer is not the spring constant? Be honest with me.
No.
I see I like that honesty. Remember, for Hooke's law, the formula was F is equal to KE. If you were to make K the subject of the formula, I would have to divide both sides by what?
E.
I would have to divide both sides by E. So in that instance, K would be equal to F over E, force over extension. But Jada, what kind of graph is this?
Straight line graph.
I know it's a straight line graph, but what kind of graph it is? What's the title? What's the title? Oh,
Graph of extension versus force
right. So what's on the y-axis?
extension.
Right? So when you find the gradient, remember is y over x. So the gradient for this would give you y, which is e, all over what? What's on the x-axis?
Force.
So let me ask you a question. Is this a spring constant? The gradient, would the gradient be spring constant?
No.
No, what's the actual spring constant?
F over E.
Right. So whatever you get for the gradient for extension versus force graph, you would have to raise it to the power -1 to get the spring constant. Yeah?
Yes.
Raising something to the power -1 just simply means you're inverting it. Right? That's what. Don't let it tire. Right? Look. But wow. Gina, look at this. Look. I'll even tell you it. You see that? Look what it's telling you. Given the gradient, S is equal to 1 over K, isn't that just the inverse of, isn't that just the inverse?
Yes.
Because Jada, if you had a graph, okay, so this graph is extension versus force, but if you had a graph of force versus extension, the gradient would be K. But for this graph, we know that the gradient would be 1 over K, which is the reciprocal, right? So they want us to calculate for the spring constant K. So Jada, how would I find for K? So just to remind you, S was equal to 4.5. S was equal to 4.5 centimeters per Newton. How would I find for K?
Make K the subject of the formula.
Mm-hmm. Yeah.
So it would be K is equal to 1 over S.
Yes. Yes, that's correct. So check it out, right? If you have S is equal to 1 over K, what you could do is you could cross multiply. So there are multiple ways you could work it out. So S is equal to 1 over K, so you can make K the subject of the formula first. So if you cross multiply, what do you end up with? What do you end up with, Jada? Some way you would end up with if you cross multiplied. So first of all, what's K by S? K by S. Wouldn't that just be KS? I feel like I'm real confusing you right now. Jada,
You heard me?
I hearing you now.
Oh, I was speaking the whole time.
Let me know if you're real confused. Like a real
No, I understand. Yes, you'd get
KS.
yes.
I'm always one by one,
One
right? I want to find for K. So I would have to divide both sides by what?
S.
Right? So K is just equal to 1 over S, like you said. Do we know what S is?
Yes, 4.5.
Right. Now I want you to be very careful about something, right? Remember, didn't it have units?
Yes.
So if you put something as 1 over, what's gonna happen is the fraction is gonna flip. Let me give you an example. If you had 1 over a half, no, let me something else. If you had 1 over a two, 1 over 2/3, then the answer would be 3 over 2. So my question is, if I had 1 all over centimeter over Newton, or what would I get? What would be the new units? Tell me, Jada. Jada?
I feel like I want to say Newton centimeters, but that ends on into right.
It could be Newton per centimeter.
Right.
Mhm.
Makes more sense.
What I'm saying is, if you have 1 over a fraction, the final answer is just the reciprocal. You just flip it.
Right.
So if the units was centimeter per Newton, then the new units would be Newton per
But
centimeter. So you understand that?
yes.
I'll leave that working to the side somewhere. So that being said, it's going to be 1 over 4.5, and the final units would be Newton per centimeter. So you go with that.
Yes.
Now, what is 1 over 4.5?
0.2.
0.2. The exact
Yes.
answer. Let me see.
0.22. And then it just goes down the line with 2.
All right. So in physics, we usually round things off to 2 decimal places. So if I round that off to 2 decimal places, what would I get?
0.20.
Now get 0.22, 2 decimal places. All right. 2 decimal places. Let me show you what I mean. So 0.222, etc. This is the second decimal place. What's the number after the second decimal place?
2.
Right? So everything after the 2, I would just drop. So 0.22. Let me know if you understand.
Yes, I do.
Right? And the units would be Newton,
Per centimeter.
or you could write that as newtons, centimeter to what power?
-1.
Correct. So I hope you understand that. So Shayna, did you get something similar? I got 0.22.
Same with I got 4.5, so yeah,
You
I'm
got
following exactly with you.
great. And did you put the units?
Yes, I did.
If you
I
didn't,
put N over CM. Yeah.
right. If you didn't put the units, you'll get 2 marks. Right? Given that F is equal to KE, calculate the length L when a force of 8 newtons is applied. Assume that the spring obeys Hooke's law. First things first, Jada, let's write the full equation, right? So Jada, if we want to write the full equation, it's going to be F is equal to what? What do we know K to be? What is K?
Spring constant.
Right. Didn't we just find that?
Yes.
What did we find that to be?
0.22
Right?
Newton per centimeter.
Right? But when you put anything into the formula, you don't have to put the units, right? So it's going to be
Right.
F is equal to 0.22 by E. Nice. So that's the formula we're going to work with. Tell me if you understand this. Remember, the original formula was F is equal to KE, but in this rounds, we actually found for K. So we know what K is. So we made a substitution. So you go with that?
Yes.
Okay, nice. Now in this question, they want us to find for length L. Now you have to be extremely careful with this question, Jada, because when you when you look at this question, would you be finding for the length or the extension? What would you be finding for? That's my question to you. We have force, we have spring constant, and we have extension. They're telling us what the force is, and we know what the spring constant is. What's the only unknown?
The extension.
But is extension the same thing as the length?
Yes.
No. This-
Oh.
Let me show you why, right? If I have this spring here just resting, wouldn't it have our original length?
Yes.
Right? So this is the original length. If I apply a mass to it now,
Yes, it would extend.
right? So you would call this the original length. You would call this the original length, and you would call this the you wouldn't call that the extension, eh? You would call that the original length plus the extension. If you want to figure out the extension would actually be this piece over here. Tell me if you understand that.
Yes.
So here what, right? And Sheena, this is where plenty students gonna make a mistake. Plenty students just gonna find the extension and call it a day. But that's not it. If you want to find, so Jira, if I want to find the new length, I would have to add the extension to what? Tell me, Jira. If I
The
want
original length.
exactly. So they told me that the force was 8, so I could make a substitution. So 8, or replace that with F. So we have 8 is equal to 0.22 E. So I want to find for E. What would I have to do on both sides? Somebody tell me, what would I have to do on both
Divide
sides?
by 0.22.
Correct. Jada, would you have been able to figure that out?
I think so. Yeah.
I think so. I mean, there's nothing different from what you learned so far. And if I want to find for E, this 0.22 gotta cancel off.
Yes.
Yeah, so I will divide by 0.22 on both sides. So the 0.22 and the 0.22 would cancel off, and that would leave me with E. So E would just be equal to 8 all over 0.22. What is 8 over 0.22?
36.36 to two decimal places.
Okay, 36.36. And we just now found for extension. What units do you think extension would be in?
Centimeters.
Correct.
Meters. Oh,
No, no. Shina, if we
oh,
look
right,
at this
right, right.
question, right?
The graph, right.
All of the units here were given in centimeters. You see how tricky physics is? You see how much room for errors there are?
Yes.
Yeah, there's a lot of room for errors. And again, if you did this, you'll only get a 1 or 2 marks. So to answer the final question, to find for the length, you would need to add this extension to the what, Shina?
To the original length.
Correct. So L would be equal to the original length plus the extension. And the original length was what again?
I think 70.2.
Right? 70.2. And the extension was 36.36. Yeah? And that should,
Yes.
and what are you all getting for that? It should be like 106.56.
Yes.
Yes, sir.
And the unit for that would be? What would the unit for that be? Somebody tell me. Units, so that would be
Centimeters.
I wanted Shina to answer. Shina.
Uh,
I wasn't gonna say it, but I realized nobody was saying it, so I was like, okay.
All right, so Shina, you understand that length is in centimeters for this particular question, right?
yes, sir.
So let's count how much marks our whole question was. Seeing 25 here, but let me not trust it. So 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 8 is 18. Well, that's a lot of marks. Wow. Jada, you see 25 marks for that one question?
Yes.
That's a lot of marks, right? That's a lot of marks. So, and I think I could get a max, honestly. So, if you could get it, get it. Shayna, and you feel like that's an easy 25 marks?
Yeah, I feel it wasn't bad.
I feel like if that come in the exam next year, you all should be fine. Now, just as a quick recap, let's do these questions fast and we'll move on to density and Archimedes' principle. So, do we know what moment of a force is? Does anybody remember what moment of a force is? Shayna, do you remember what moment of a force is?
Sorry, sir. Huh?
Do you know what moment of a force is? It's just a recap from what we did in the last.
Um, I know the formula for moments.
Okay. What's the formula for moment?
The moment equals external force times this perpendicular distance from the pivots.
Right. That's good enough, right? If you put that, you'll get full marks. So the moment, right? So the moment of a force is the product of the force, right? Of the force by the perpendicular distance from the pivots. Yeah, Jada, do you remember me saying that? I mean, the formula for M was equal to F by D.
Yes.
Okay, good. Right. And you're sure you know that. Just confirm with me. Jada, you sure you're good to move on?
Yes.
Okay. Shina, you good, right?
Yes, sir.
Right. This should be a capital M. Nice. Now, center of gravity. You gotta remember what center of gravity is. I'll give you all a hint. Imagine you held a pencil at the center. When you hold a pencil at the center, you are able to do what with the pencil? Tell me, Jada.
Stop.
If, oh, yeah, Jada. If I have a pencil and you put the pencil directly, you take your finger and you put this and you support the pencil directly at the center, what's gonna happen to the pencil? Jada? I'm not hearing Jada.
Yeah, hold on. Hold on, depends.
You serious? Serious? The
Why?
long story short is you'd be able to balance the pen.
Yes.
And so if you want something to be upheld, you want something to be in equilibrium, you want it to be um stationary, then for that to happen, the net forces must be zero. So Jada, what's happening there is that at the center of gravity, the entire weight of the object is acting down. And so by you holding it up with your finger would generate a force that's equal to the downward force, which is the weight, but in the opposite direction, and that would cause the pencil to remain stationary. Just to draw a diagram, I'm sure what I'm talking about. So if this is your finger here, and I need you to understand that the center of gravity is where the entire weight of the object would be acting. So by you holding it up with your thumb would exert a force that's equal in magnitude but opposite in direction, and that would cancel off, and that is what causes the pencil to remain stationary. Do you understand that? Kalmajira?
Yes, I do.
Okay, good. So in long story short, the center of gravity is the point at which all the weight of an object acts. That's the center of gravity, right? The point in an object where all of all of all of its weight acts. Right. Does everybody understand that?
Yes.
Right. Okay, state two conditions necessary for a body to be in equilibrium. For a body to be in equilibrium, the upward forces must be equal to the what, Jada?
The downward forces.
Right? And the clockwise moments must be equal to the
Anti-clockwise moments.
right. Nice. So far we get 3, 4, 5, 7 marks. Lovely. Lovely. Right? Physics is very easy to pass. I'll say that much. So, Jada, I call it on you plenty because I know you doesn't be able to join much like all the classes. So I need to make sure when you hear you understand. So don't take it as personal. Actually, you should take it as a compliment because I want you to mash up the physics, right? So be brave and work the question with me. So I want you to read part C for me. Read part C.
Figure 2 shown below is a diagram of a non-uniform wooden plank, AB, which is 2.0 meters long and weighs 1,000 newtons. The
Okay,
plank
wait,
is
wait,
oh,
let me
okay.
stop. Wait, I want you to pay attention to something, Jada. They said that the diagram is showing a diagram of a what wooden plank. A what? The plank is
And non-uniform.
if something is non-uniform, do you think the center of gravity would be in the center of the object?
No.
And you could see that the center of gravity is actually kind of not at the center.
Yes.
Yeah, that's because it's non-uniform. And this is actually a very nice question because in all the questions you would typically see a uniform plank, right? So continue.
The plank is supported from a ceiling by two vertical springs, P and Q. The plank is attached at a distance of 0.5 meters from each end. C is the center of gravity as shown in figure 2.
Right. So we good, right? Some of you okay.
We're fabulous.
Like fabuloso. Or
Someone.
or we're fantastic like Fanta. All right. So Jira, you have a wooden plank that's being held up by two springs. First things first, weight is a force that acts what? Upwards or downwards? Weight. Where does weight act? Upwards or downwards? If somebody sits down on you, especially a fat person, will it weigh you up or weigh you
Downwards.
downwards, right? Cool. Now, if the springs are holding up the I find this funny because we just don't look at springs, right? So Jada, if these springs are holding it up, would the springs be exerting a downward force or upward force? What do you think? Farmer Jada, what do you think? If the
I
spring is
think it
holding
would
up,
be upwards.
yeah, it would be upwards because And if you want to hold up this wooden plank, wouldn't you have to exert a force upwards on it?
Yes.
Yeah, so these springs would be exerting an upward force, right? Cool. So I'm glad we're on the same page. Shina, are we on the same page?
Yes, sir.
So Shina, how much pivots do we have in this diagram?
2.
2, right? Jira, be honest with me. Can you see the 2 pivots? If not, tell me now.
Yeah, I think so.
I don't like that thing so. You gotta be 100% sure. Is that a yes or no?
Let me take my chances and go with no.
Okay. So a pivot is a point about which rotation could happen. I think you know that. So
Yes.
imagine if this spring were to snap. Wouldn't rotation happen about this point? Think about it. If this
Yes.
snap, wouldn't that plank go in that position?
Yes.
Cool. So rotation can happen about this point. That's a pivot. If this was a snap, wouldn't the wooden plank now pivot about this point?
Yes.
Right. So 2 pivots. Anytime you're dealing with a 2 pivot system, you're going to pick one pivot and work on that one pivot. So let's see what the question is asking of us. When the plank is horizontal, the tension in spring P is 600 newtons. So Jada, that upward force I was telling you about would be tension in this instance. Because you can imagine if you have a string holding up something, wouldn't there be tension on the string?
Yes.
Right, it's the same thing over here. Spring is like a metallic string. Cool. Calculate the tension in spring Q, show all working. This one isn't so bad. So Jada, tension, upward or downward force?
Upward.
Yeah, tension is our upward force, right? Because it holds up something. So at P, I'm going to draw an upwards force, and I'm going to call that 600 newtons. Are you confused or you're understanding?
I understand so far.
Right. Now, for a system to be in equilibrium, what do we know about the forces?
The total amount of upward forces are equal to the total amount of downward forces.
Correct. So you have an upward force over here, and wouldn't you also have an upward force over here? Because that's another spring.
Yes.
Okay, do we know what that force is?
No.
No, so we could call it Q if we want. I mean, Q, it only makes sense, right? We call it Q. All right, so we don't know what that is. Do we know what this downward force is?
Yes.
So we could form an equation, right? So you could say upward forces is equal to downward forces. Right. What are the upward forces? We have 600. So I'm going to say 600 plus what?
Plus Q.
Right? Plus Q. And what's the only downward force we have?
C, which is 1,000 newtons.
Right. So if I wanted to find Q, what would I do next? Think about it, Jira. If I want to find for Q, Q is the only thing I want on the left-hand side.
U minus 600 from 1,000.
Yep, that's correct. Another way to think about it is you're going to move across positive 600. So if you move positive 600 across, it's going to turn to negative 600. So Q is going to be equal to 1,000 minus 600. And what is that going to give you?
400.
Right? 400 newtons.
400 newtons.
Right, so that's the tension in spring Q. So let me know if you fully understand that question.
Yes, I do.
Okay, nice. All right, in part two, by taking moments about A, determine the horizontal distance from P to C. All right, so let me just take this diagram and I'm going to put all of the information on it. Okay, cool. So, Jada, we found the tension on Q to be 400 newtons, right?
Yes.
Right. Jada, are we okay so far?
Yes, sir.
Okay, cool. Now, just one small adjustment. Jada, if you have a spring like this, do you think the upward force will be over here? Do you think you'll be over here? What do you think? Jada, I'm not hearing you. What do
I
you think?
think it would be yeah, this you could put numbers.
Yeah, put on.
One, it would be over one.
Shana, what do you think?
I think it'll be option one.
So that again?
I think it'll be one.
Now, let me try to understand something, right? This spring, wouldn't this spring be pulling upwards? Think about it.
Yes, sir.
So either one is correct, but I feel like the one that would make more sense is that. Why am I saying that? Because if this is the other end of the spring, wouldn't that other end of the spring be pulling upwards?
Yes, sir.
Yeah. So I'm gonna go with that instead. I prefer that. Right? So let's put that here. Okay, cool. Right, Jada, you understand what I'm saying? If you have a spring over here, and this is the other end of the spring, so you can't do anything with this end, right? That end attached to something. Wouldn't this end of the spring be pulling this plank upwards like that?
Yes.
Yeah, so that'll make more sense. Okay, cool. Nice. So let's answer this question quickly. So by taking moments about A, determine the horizontal distance from P to C. Okay, so Jada, this is an interesting question, right? Because it's telling us to take moments about P. I guess in the two of you would have never seen a question like this, yeah or no?
Yes.
Have you ever seen a question like this? Where they telling you
Mm.
to take moments about A? I thought they'd tell us to take moments about P and Q, but that's fine. We'll still get through, right? Jada, have you ever seen a question like this?
I think so.
Think so? All right, well, let me handle this question fast. So, Jada, they want us to take moments about A. So, I'm going to treat A as if it was the pivot. That's what I'm going to do. I treating A as if it was the pivot. So, imagine you had a bearing or something over here that we're saying that that could be the pivot. We're saying that. Interesting, but we're saying that. And we want to figure out the horizontal distance from P to C. P to C. All right, so Sheena, I want you to help me with this question. So do you understand everything we have so far?
So far, yes, sir.
Okay, cool. What do you suggest next? All right, so Sheena, this question is a bit tough, right? So I'm gonna kind of guide you. Sheena, do we know what this distance is?
No, sir.
What do you call something you don't know in maths and physics?
X. Or
Right,
some unknown.
it's called x. So let me ask that question. Isn't there, don't we have another unknown length?
Yes, sir.
We do. This is also another unknown length. So my question to you is, if we read the question, right, you would see that they said the plank was 2 meters long. So we know that the entire plank is 2 meters long. So from here to here is 2 meters long. 2 meters, okay? So the entire thing is 2 meters, right? And this is 0.5. This is x, and this is 0.5. How would I find for this length in terms of x? See if you can figure that out.
Um,
I'm gonna make it simple for you. What if we had, I'm just gonna put a value here, right? What if we had a value here of, I don't know, like probably 0.4? How would I figure out this length over here? Angela, you could answer as well. If this was the case, how would you all find for the other length?
you could add up all and subtract it from the 2 meters.
Exactly. So we could do that with x, right? We could do that in terms of x. So, don't know what happened to the arrows, but we shall move on. Right. So, Shayna, let's add up all the quote-unquote lengths. So we have 0.5 plus x plus 0.5. So it's going to be 2 minus open bracket 0.5 plus 0.5 plus x. Tell me if you understand that,
Yes, sir.
right? What is 0.5 plus 0.5,
1.
right? Then you would need to expand, and you should get 2 minus 1 minus by positive x is minus x. What is 2 minus 1,
1.
right? So you then I put 1 minus x. Let me know if you understand that.
Yes, sir.
Cool. Now, Jada, I understand that might be a bit troublesome. Would you like to see an easier way to work it out? Let me know if you,
Sure.
but did you understand that?
Yes.
Okay, let me show you an easier way to do it. So, Jada, we know the entire thing is 2 meters long. We also know that this 0.5 and this is 0.5. So, what's the remaining length then? What's the remaining length?
1.
1. And if this is x, that would make this what?
1 minus x.
Yep. Easy, right?
That's how I was doing it in my head while I was doing the working thing.
That's correct. That's fine. All right, so both methods are correct. Shana, which one you prefer? The working or just seeing that this would be 1, and if that is 1, right, then this would just be 1 minus x, because I would take away x from it to find the remaining portion.
So the second one is more simple.
Okay, no problem, right? So now we need to figure out which one is the clockwise and which one is the anti-clockwise moments. So if this is the pivot, let's see what's going to happen if we apply an upward force. So imagine this is the pivot and you pull upwards. Wouldn't the wooden plank want to go in that direction? Tama yeah or no? Jada. Might be a bit confusing, so let me run that back one more time. Jada, you there?
Right here.
Okay, good. So Jada, this is a point about which this wooden plank could turn. So imagine you have this thing here and you pull upwards. If this is a pivot, wouldn't it want to rotate in this direction like that?
Yes.
You sure you understand that?
Yes.
Okay. So would we call that a clockwise moment or anti-clockwise? What direction is that going in?
Anti-clockwise.
Right? So this is an anti-clockwise moment. Okay. And the same thing over here. If you have this is the pivot and you apply an upward force, you're gonna want to rotate in this direction. So clockwise or anti-clockwise?
Anti-clockwise.
And in this particular question, how much downward forces we have?
1.
We just have one, right? So imagine this is the pivot again, and you pull it down. Wouldn't you want to rotate like that?
Yes.
Yeah. So what would that be? Clockwise or anti-clockwise?
Clockwise.
Right? And we know that the system is in equilibrium, so we could now apply the rule, you know? Clockwise moments is equal to anti-clockwise moments. Right? So anti-clockwise moments is equal to clockwise moments. Great. So guys, let's first figure out the anti-clockwise moments. So Jada, if we're treating this as a pivot, we have a force here of 600 newtons, and what distance is it away from the pivot?
Wait, you could like repeat that, please?
All right, so this is the pivot, and this is the force we are considering. We're considering that force over there of 600 newtons. How far is it away from the pivot?
0.5 meters.
Right, so remember, moment, capital M is equal to force by the distance from the pivot. So the force here is 600, right? And I would multiply that by the distance from the pivot, which is 0.5. Understand?
Yes.
Then we're going to add that to the other anti-clockwise moment. So tell Majida, this force here is 400 newtons, and how would we calculate how far it is from the pivot? I promise it not as hard as you think.
You would add 1 meter to the 0.5 and get 1.5 meters.
Right, so that's 1.5, right? Because
Right.
think about it like this, Jada. The entire thing is 2 meters, and
Yes.
if the entire thing is 2 meters, if I take away 0.5, wouldn't this be 1.5?
Yes.
Cool. So that's going to be well, let me put the force first. I'll be 400 times 1.5. Sheila, did you catch that?
Yes, sir. Well, I was talking true.
Okay, good. And so Sheila, tell me what the clockwise moment would be. So the force there is 1,000. And what is the distance from the pivot? Sheila? I'm not sure what happened with Sheila. All right, Jada, how would I figure out the distance from the center of gravity to A?
It would be 0.5 plus x.
Right. That'd be 0.5 plus x. And I have to put that in brackets, okay? You'll see why. So let's work out the left-hand side. What is 600 by 0.5? So, Jada, what's half of 600?
300.
Right, that's what it means. So 0.5 is just half. What is 4 by 1.5? So imagine adding on a half of 400 to 400. So half of 400 is 200. 200 plus 400 is
600.
600, right? Right, and that would be equal to 1,000 by 0.5 plus x. You'll see what's going to happen in the next line. So you see everything inside our brackets. I would have to multiply everything by 1,000, right? On the left-hand side, Jira, we have 300 plus 600. What is 300 plus 600,
900.
right? And that would be equal to 1,000 by that entire thing. What's 1,000 by 0.5?
500.
500. Mm-hmm. And what is 1,000 by positive x?
1000x.
Right. What's the next step? What do you suppose is the next step?
You wanna find for x.
Mm-hmm. Want to find x?
So you take. Okay, hold on. Let me find the easiest way to see this.
Should I help you? Hmm. Should I lend any assistance?
Okay, so you put positive 500 over the equal sign, so it would be minus 500
Right.
from 900
So we can say 900 minus 500.
is equal to 1000x.
What is 900 minus 500?
400.
Right, so 400 will be equal to 1,000x. So to find for 1x, what
Yes.
do you want both sides?
You divide by 1000,
Mm-hmm.
and you would get 0.4 meters.
Right, so x would be equal to 0.4 meters. Let me know if you understand that.
Yes, you hear more cricket in the background.
Yeah, I hear it.
That's the cricket you'll be talking about.
Yes, sir, yes, sir. Mm-hmm. That one partner. Right? So there was an easier way to work this question out, but they specifically told us to take moments, so we had to do this method. But you want to see the easiest way to work this question out?
Yes, show me.
So, like, even if you don't remember this, you can still get some marks. You understand the part where I said that this was x and this was 1 minus x, yeah?
Yes.
Okay, cool. And we know that from here to here is 1.5. We know that.
Yes.
So watch this, right? Watch this carefully. And if I add up all of these lengths, what's supposed to get? That's supposed to be equal to what?
1.5.
Yeah, so watch that, right? I could say 0.5, 0.5 plus x plus 1 minus x, and that's supposed to be equal to,
1.5.
right? 0. Let me group together the like terms here. Oh, but wait, something is going to happen. I don't know if you could spot what's gonna happen. What's gonna happen with the x's?
It would be x squared.
No, it's x minus x.
Oh, x
No, if I
would be 0.
it'll be 0, right? So if you do this, the x is gonna cancel off. 1 plus 0.5 is 1.5. It's not gonna help you. I mean, yeah. You see what's gonna happen there, right, Jada? It can't help you. I mean,
Yes.
you're just gonna get 1.5 is equal to 1.5. That's not gonna help you find facts. So I guess the only thing you could do is to apply moments, right? So let me know if you understood how I did it,
Yes, I do.
right? Shayna, what about you? Do you understand how I got 0.4?
Yes, sir.
Okay, nice, right? State why the center of gravity is located closer to point P than point Q. Do you think you have a reason for this, Jada?
Um, I think there is, yes.
All right. So let me go up to the start of the question. In the start of the question, what did they mention about the wooden plank?
It's not uniform.
It's not even. So Jada, it was a non-uniform wooden plank. Jada, if you have a uniform wooden plank, wouldn't the center of gravity be exactly in the center?
Yes.
But is this a uniform wooden plank?
No.
No. So the easiest answer for this would be, right? It would say, so you need to say this and you need to back it up with something else. So I'll put that in as well. So the center of gravity is not at 1 meter because the wooden plank is not uniform. All right, so that's one reason there, right? And let me think. So that's the main reason, right? All right, and Shina, let me run through something. If you want to create a greater moment, the distance should be closer to the pivot or further away from the pivot.
Further.
Further away from the pivot. Okay. So let me understand something, right, Shina? If we look at the diagram, which spring had a greater force?
P.
P, right? P had a greater force. But then, okay, wait, I'm gonna pause there. Now, logically, I would say that it closer to, they was asking why it's closer to P than point Q. I would say, so Shina, and she could see that P has a greater tensile strength, it has 600 newtons. Seeing 600 there, and over here seeing 400, yeah?
Yes, sir.
Right. If this string is supposedly more stronger, wouldn't the weight, but you see weight can't change, so I mean that center of gravity can't change, it would have to be over there. Basically, you would say that you could say that majority of the you can say that the density was greater to which side? So Shayna, they said it was non-uniform, right? So where do you think the density would be greater? Make a guess. Where do you think
Right.
say that again?
Right.
Yeah. The density was greater to the left, so the weight had to be closer to the spring P. That's it. But the whole point is that it wasn't uniform, so that's why the center of gravity is closer to point P than Q. I will get a better answer and put it in the document. But that's essentially it for class today. So I know I wanted to start density and Archimedes principle, but I'm happy that we get to do some difficult questions. Right? So Jada, um, tell me if you understand how to do a Hooke's law question. Do you understand how to do a Hooke's law question?
Way better than when I was in Form 5, yes.
All right. So before we end class, I'm just gonna do a little summary and then we're gonna call it a day. Right? So when we look at our Hooke's law just basically talks about the extension of a spring. If you have a spring and you apply a force to it, it will extend, right? Now, this extension has to be within the elastic limit. If you stretch a spring too much, it would not be able to go back to its original position. So I would say that the elastic limit is exceeded. You have to know that. You understand? Tell me if you understand, Ajira.
Yes, I do.
Right. Now you need to know the formula for Hooke's law. The formula is F is equal to,
KE or
right,
KX.
perfect. If I want to find for K, I would have to divide both sides by E, and I'm going to end up with F over E. Understand?
Yes.
So the only way I'm going to get spring constant directly is if I have a graph of what versus what. think about it, right? Think about the gradient. Remember, gradient is y2 minus y1 over x2 minus x1. So y over x. So which graph would give you Gina? I want Gina to answer. I feel like you know the answer, right? Yeah. Gina, I want you to think of a spring constant as being a gradient, right? So what would the axes have to be here and here to give you a spring constant immediately? Remember, a gradient is y over x essentially. To see if you can figure it out, Gina. So Gina, we know that k is equal to f over e, right? And we know that gradient is essentially y over x. So Jada, what do you think I should put on the y-axis if I want to get spring constant from the gradient directly?
A
Jada,
number.
I looked at one, I didn't realize it. Jada, there?
Yes.
Yeah, a bit confuffled.
Kinda.
Okay, let me run through back a concept that's very simple. And you know that gradient is y2 minus y1 over x2 minus x1?
Yes.
Right. So if I want to find the gradient, and I would take 2 points and I would like on top, what I would put on top is the y values. Now, look at this, right? Look at this carefully, Jada. To find for k, it says force over extension. So I want you to imagine you have a graph and you're finding gradient for the graph. For you to get spring constant, you need to get F over E. So what do you think I should put on the y-axis if I want to get the spring constant? I'm gonna run that back one more time. Imagine you have a graph of something versus something, so we're trying to figure out what the axes are. And you know that gradient is essentially y over x. What would I need to put on my y-axis and my x-axis to get k? So look at the formula for k and you'll get the answer.
Force.
I need to plot force versus,
Extension.
right? You understand it now?
Very much.
Because from the formula, k would be equal to f over e. And so whatever graph you do, the axis must be force over here and it must be extension. Because when you find a gradient, it's essentially gonna work out to be force over extension, which is the same thing as spring constant. So if you have a graph of force versus extension, when you find a gradient, you'll get the spring constant immediately. Understand?
Yes.
If you have a graph of extension versus force, though, you're gonna have a little more work to do. Understand? Because
Yes.
if you find a gradient for this, it's gonna come like you find an extension over force, which is actually equal to 1 over k, the inverse of the spring constant. So that's the main takeaway I want you to, to learn from Hooke's law. You also need to remember when you're plotting a graph, you need to put a title for the graph, right? Is usually y versus x, whatever you have on the y-axis versus whatever you have on the x-axis. You need to put the scale. Just remember, Jada, you can't use a scale that's a multiple of 3, and whatever scale you use, it must occupy more than half of the graph. Also, don't forget to put your scale, and in your scale, you have to put units, and that's essentially it. So you understand everything there for Hooke's law. Yeah or no?
Yes.
Okay. Do you remember the formula for force? Now F is equal to KE, yeah? Got a
A
formula,
mass by acceleration.
right? And another way to write that is W is equal to weight is our force, right? So weight is the force is equal to mass times what?
Gravity.
Nice. On Earth, what do we typically use as the gravity? We just typically use 9.8 ms minus 2 or 10 ms minus 2. Right? It will change per question. Sometimes you might see use G as 9.8, sometimes you might see use G as 10. Right? In the case of the question we had, we realized that gravity or acceleration was 10. They had used 10, right? So you need to know this formula for force. And what else you need to know? You should also know that the new length would actually be equal to the original length plus the what? Tell me, Jada.
The extension.
Perfect. Perfect. And if I wanted to find the extension, what would I do?
Minus the new length from the original length. No, minus the original length from the new length.
Great. Because the new length will obviously be bigger, right? Because if you apply a mass to a spring, the spring would extend, so this new length would be more than the original length. So I feel like you understand everything there, right? It looked like I erased something here. I thought we just not seeing it. I'm confused. And for some reason we just not seeing it. I think when I export it, it should be it should show, right? And Jada, just to give you a recap on moments, you need to remember moment, capital M is equal to F by D, right? A moment is the product of a force by the perpendicular distance from the pivot. That's what it is, right? That's what moment is. Moment is F by D, and D is the perpendicular distance from the pivot. Center of gravity is the point in an object where all of its weight acts. If an object is uniform, all the weight would act in the center. You understand? So, like, if the density throughout the material is the same at every point, then you could hold it at the center and it would balance the object, like a pencil. Understand? Tell me if you understand that, Gina.
Yes, I do.
But like in this diagram, in this question, right, was the object uniform?
No.
Nah, so since it wasn't uniform, the center of gravity was kind of more to the left. Yeah. And Jada, you could understand if something is not uniform, then at different points it would have a different density. Does that make sense?
Yes.
Yeah. So where do you think where do you think the plank was more dense? Closer to this side or closer to this side?
Closer to the left side.
I agree. If I make this side heavier, wouldn't I need to shift the center of gravity more to this side?
Yes.
Yeah, I would need to do that. Right? So tell me if you understand it.
Yes, I do.
Tavon, I know you just randomly joined in here for the plot, but like you understand what I'm saying about the pivots?
Mm-hmm.
So like you understand that if something is non-uniform, the density would be different in different regions. And
Yep.
you could think about a pencil, right? A pencil is uniform, so the center of gravity would be in the center. But like if you think about it, and Jada and the rest of you guys, or they could try it with a pen. Enter a pen let's have a cover. Yeah or no? Tell me.
Mm-hmm.
What you could do is if the pen have like a heavy cover, you could stick it to the back and see how the center of gravity changes. If so, like in this example, if you made here more dense, then the center of gravity would actually shift closer to here. That's what would happen. Tivon, and you can imagine that.
Mm-hmm.
So
I think you could imagine it with a seesaw now. Because like if the center of gravity is if the pivot point is like different, like you might need more weight on one side for lift the other side.
yeah, exactly. That's exactly it. I would put on my camera about looking real rough. Actually, um, let me see if I could give Ole like a good example. I'm gonna try to find something that's kind of not uniform, and I'll show you an example. Give me a second, guys. Okay, I have a perfect example. Okay, nice. I have a perfect example, right? So Ole, don't get started, right? I want to put on my camera. I looking like in a horror movie.
Man, I think he looking rough, boy. But you lie.
Nah, looking rough, right? All right, so guys, would you all say that this is uniform? Yes or no?
No, sir.
No.
What is making this not uniform?
Heavy ass thing on the
The
side.
next
This
one.
Siobhan, language, Siobhan, I will remove you from these meetings, eh? Language.
I couldn't help it.
But for those who don't know, Siobhan is my partner from university, right? She'll just be joining these sessions for the
I have this like a similar example because I have a pen with a big thing on top of it too, a unicorn, and I pick it up.
nice. So guys, if that is the case, right, would the center of gravity be, I think the answer to the question, right? No. No. The center of gravity would not be in the center. Does everybody understand that?
Yes.
Yes, sir.
So if I move my finger here, which is the pivot, to the end here, it will fall along faster, right? But if I move my finger closer to the heavy object, watch. What happened there? What happened there?
The balance now.
Find the center of gravity.
So, guys, I want all to take away this, right? This is not uniform because of this rubber on this side. So that would make the density over here, quote unquote, more, right? I'll have more material on this side. So this side is going to be heavier. So the heavier side, right? So the center of gravity would move towards the heavier side. So that's the response you should put. Does everybody understand that?
Yes, sir.
Right. Jira, let me know if you practically understand it, not just like theory, but like in practical.
Yes, I do.
All right, nice. In my classes, I just try to teach students how to think. I don't want it just to remember a formula and just move on with all their life. I want it to like actually understand what's the purpose of everything and like how it does work in real life. Because that's the important thing. School will show you that. My school will. Like when I get like real big, I'm gonna open up my school. So Jada, you go send your children to my school, right?
My children.
Yeah, when you have kids, I know you're young. But
Oh, yeah, for sure.
but like when you in future, no? Yeah.
For sure, for sure.
Devon, I hope you're sending your children in a different country. We
No, I will make sure give them a passport, make sure they get like a good set of sushi pay, and then just send them a school this.
nice, nice. Shit, now when you have kids, right? I hope you send them to I don't I didn't figure out a name yet. Shit, like, you wanna help me come up with a name for the school?
Oh, I've never that creative. I've
No,
never have done that creativity.
right now I just call my business math vibes because I mean you teaching math and thing, but obviously this school will be teaching other things. So like let me brainstorm my name right now. What name I think we could call it? Hmm.
If it's a school, you have to name after a founder.
Oh. Hmm.
So,
Jada, what you
a piece of name. I wonder if I could fabricate something, boy.
Jada, what you think? Give me a name. A quick draft.
Rajiv's Vibes Academy.
What?
I read that. 10 out of 10. Put it in.
I think that was perfect, sir.
What the hell? Now
Boy,
what?
put up on the banner, boy.
Wait,
Or
Regime
if you don't like Academy, we could go with Rajiv Vibes Institute.
Institute of Vibes by Rajiv Warika.
Ooh, yeah, that's actually so
That's
cool.
swag that.
Institute of Vibes.
Well, I'm gonna write it down in the
Mm.
notes before I forget. Right.
Institute of Vibes.
Institute of Vibes. I spelled vibes wrong. What do you? I tell you, I don't know what I drink today. I don't know what I drink. I swear. The only thing I drink today was punch. Unless it had something in the punch. Unless and if that was the case, you'd call it punch, huh? But I just drink punch today and I just drink water. That's all I drink. I don't know why. I don't know why.
Man, check it. A punch on, boy.
Hey,
I careful nowadays.
yeah. So
Absolute boy.
yeah, like I find like Tivon, let me explain this, right? Our maths classes is be today. Today is supposed to be art math. I come into class thinking physics today for some weird reason. I don't know why.
Yes, wait. When was that? When was that? This month, like earlier?
No, no, this session right now is allotted to art maths. This is not physics. I don't know why I decided to have physics today. But like when I start class, Shayna was in class now. And Shayna didn't tell me anything about it. Shayna, you
Yeah.
went
Not because I didn't know if I was going crazy. I was like, okay, I guess this is so
uh, you had to, you
I
had to,
followed it.
you had to get into the habit of
So
correcting
you
me.
just switch. So you just switch the art maths and the physics times then.
Boy, yes, yes.
Math or physics said it was good, so I'm glad it was switched.
Well, I'm happy to hear it was good, right? Angela, do you appreciate seeing like the actual practical examples as opposed to just pen
Yes.
and paper?
Yes.
Like it's make a lot more sense in practicality, and yeah. So for the last one,
Definitely.
yeah, you were saying something?
I just said definitely.
That was good. So the answer for part three has to do with right. So we already established that it was non-uniform. So we could say there was more mass to the left of the planet. Yeah, that's a good answer. That's why it's happening. So yeah, I hope I have a great evening. Right? Yeah, later everybody. I'm gonna teach pure maths now.
Right, so have fun.
Thank you. Later.
Later. Hey, I drop in this cricket for you tomorrow because you seem to appreciate it more than me.
Wait, what?
The cricket, I drop in it for you tomorrow because you seem to appreciate it more than me.
You're gonna kill it?
No, I'll put it in a container and bring it for you. I'll put it in a cage and bring it for you.
What the hell? Hey, I think you're talking about cricket the game. I thought you were telling
No,
me,
no, 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 no. This thing making noise in my head.
well, pressure the I already
So you
have.
thinking it's a whole board. That's a cricket, right?
Oh, the one thing is that whole bird, yes.
Yeah.
No.
That's like
Devon,
a boy. What the hell?
Devon, I guess the singleness starting to get to you.
Oh my
Yo,
god.
You think it's
like
a
thinking
bird?
this girl like have like boards like because I know boards does tweet and thing and like damn.
All
That's
right.
why I ain't say nothing.
All right. So yeah. Later everybody, hope you have a good night. Devon, I will let you know if you could join the Pure Math session.
Well, all right then.
Later, everybody.
Yeah,
Later.
man.
What is with it later? Oh, later.